In this lesson, we'll learn A-level chemistry shapes of molecules using VSEPR theory to predict bond angles and explain exam answers. For molecule shapes, start with VSEPR. The important idea is simple. Electron pairs around the central atom repel each other. First, count the regions of electron density. Then remember that these regions spread as far apart as possible. Finally, when you name the molecular shape, use the arrangement of atoms, not just every electron pair. If there are no lone pairs changing the shape, use the basic pattern first. Two bonding regions give a linear shape, with a bond angle of 180 degrees. Three bonding regions give trigonal planar, with 120 degrees. Four bonding regions give tetrahedral, with about 109.5 degrees. In an exam answer, state the shape and the bond angle together. Now, add lone pairs. Lone pairs repel more strongly than bonding pairs, so the bond angle becomes smaller. Methane has four bonding pairs, so it is tetrahedral, 109.5 degrees. Ammonia has three bonding pairs and one lone pair, so the molecular shape is pyramidal, about 107 degrees. Water has two bonding pairs and two lone pairs, so it is bent, about 104.5 degrees. Use the same routine every time. Count the regions around the central atom. Check whether lone pairs change the molecular shape. Name the shape using the atoms you can see. Then give the bond angle and explain any compression. That is the reliable pattern. Count regions, check lone pairs, then name the shape and angle. Question A asks for the shapes of water and boron trifluoride. We need to match each molecule to the correct shape using VSEPR. Read the table carefully. For water, think about two bonding pairs and two lone pairs. For boron trifluoride, think about three bonding regions and no lone pairs on boron. Water has two lone pairs, so the molecular shape is nonlinear. Boron trifluoride has three bonding regions arranged evenly, so its shape is trigonal planar. So the correct answer is D. Water is nonlinear, and boron trifluoride is trigonal planar. Question B asks which shape is correctly predicted by VSEPR theory. This is really testing whether we count bonded pairs and lone pairs separately. Look across the rows. The key case is three bonded electron pairs and one lone pair. That gives a tetrahedral electron pair arrangement, but a pyramidal molecular shape. A quick check is ammonia. Nitrogen has three bonds and one lone pair, so the atoms form a pyramidal shape. Always name the shape of the atoms, not the electron pair geometry. That means the correct answer is C. Three bonded pairs, one lone pair, and a pyramidal shape. Question C uses histamine. We need to put bond angles X, Y, and Z from the smallest to the largest. Start by locating each angle. Angle X is close to a nitrogen with lone pair compression. Angle Y is around a more open single bond region. Angle Z is in the trigonal planar ring system. Lone pairs compress bond angles, so X is the smallest. The trigonal planar region is about 120 degrees, so Z is the largest. That leaves Y in the middle. The order is X, then Y, then Z. So the answer is A. Before you answer shapes of molecules questions, count electron regions first. Separate electron geometry from the final molecular shape. Remember that lone pairs compress bond angles, and always state the shape and bond angle together. Check bonding pairs, lone pairs, and repulsion before you write the final answer. Keep practicing with real exam questions on EduNinja. Build papers by topic, follow step-by-step solutions, and review smarter at eduninja.net.